Assalamualaikum and good evening. Today I'm going to review my final assessments of the Introduction to Electrical Engineering subject. My metric number is A203666 and I'm going to cover two questions for the final assessment. So we move on to question number 1, which is from the Rizzoni book of chapter 3, AC Network Analysis. So we were given an unknown circuit as shown as this figure number 1. So we know that it gave V input and V output, and then over here unknown circuit which we have to create later. This is also the graph of V input and V output voltage that was given. So question number 1. Propose a circuit with drawing that yield the result in figure 2. So for me, I'm going to take the question B because my metric number ends with an even number. My metric number is 203666, so an even number. So I'm going to take question B, which is I'm going to use resistor and an inductor. So and then question number 2, support your answers with simulation from Ltspice. So we're going to see the simulation first. So I'm going to open up my Ltspice, and this is my test. We're going to redo it. I'm going to redo everything again. Don't worry. All right, we removed everything. Okay, we're going to start now. So first, of course, we need the voltage source. So we just put a voltage source here, and then we need to have a resistor. So we put resistor here, but we want in horizontally. So we just rotate them, put them over here, and then find the inductance, which is this one. Put it parallel to the voltage source, like that. And then every circuit need to have its ground source, which is the voltage equal to 0. So we just put it down here. And then we connect all of it. Simple as that. I'm gonna do all right. Okay. And then we're gonna connect the ground. So we got our plain circuit over here. Now I'm going to put on the values that I've given based on the graph over here. The graph here. So we know a couple of things like the voltage values and the time. And we're gonna start it. Just right click and then go advanced. I'm gonna put in an on sine. So put it on sine, and we have the amplitude, which is we're gonna go with 5, and then the frequency. All of these values will be shown on my calculation after this, and the frequency is 8 hertz, and the degree is 90. Sine sinus. And then we just click OK. It will be obtain values like this, and then we're going to put the resistor value, which is 1 kilo ohm or 1000 ohm. Click OK, and then we're going to put the inductance value, L equals to 15, such as stated in the graph and the question. Next, we're going to run the simulation. Just going to press this run button. Oh, the time as shown here, it's the maximum is 250 in milliseconds. So we're just going to put 250 milliseconds for the time. 250 milliseconds. And just click OK. So we got a plot of graph here, a graph paper. It resembles a graph paper. So we're just gonna wait. I'm just gonna small that. Okay. I'm gonna minimize. All right. Then maximize this and zoom it a little bit. Yeah. So you can see them clearly. And then we're going to I forgot one thing. We're going to label V input and V output, which is also very important. Forgot. So this is V input is coming from here, and V output where the voltage comes out. I'm gonna do it again. V out, just like that. Okay, and then here we have our circuit. Just gonna click over here until you're gonna click run, and then you see here like where the voltage start and where the voltage will end. So we're just gonna put it on V input over here, and then we will get this graph with their own amplitude, 60 milliseconds, 180, and max at it reach at 5 volt and -5. And then we're gonna do another one which is to V output, and then we got another one over here. So the simulation will, this graph should resemble the one in the question. As we seen, this is the graph that we got, and this is the one that we have in the question. Let me zoom in. Yep, it's almost identical. Output is like way shorter and way it has less amplitude compared to of the V input. Same as this one. The blue one is the output, V out, and then the green one is V input. Okay, so we're going to move on to the calculations, which is going to answer the support your answer with calculation. So this is my calculation. We have the circuit here that I have drawn. It is a very messy one. I'm so sorry. Uh, as we can see, it's almost the same as what I did in the simulation here in Ltspice. Identical. Okay, and then we start with the calculation. So VT equals to V input equals to uh, IR plus V output. And then we have VL equals to V output equals to I plus J omega L. So we know that I is the current, R is the resistance, and uh, omega is what we will get with our values that have been inputted. So we know that V input is 5 volt as seen on the graph here. V input is 5 in the maximum one. And then at the 90-degree, because we do it in the sinus circuit. And then we got a frequency of 8 hertz. And then we can calculate the omega by inputting the by substituting the frequency value into the uh, to the general formula, which is 2 pi f, and we just substitute then 2 pi times 8, and then we got 16 pi rad per second. So remember to put your calculator on rad mode. Do not put in degree mode, or you will not get the answer. And then we're going to continue with the calculation. Z total equals to ZR plus ZL. R on the resistor and L on the inductance. So we already got the R1, ZR1, so which is 1 kilo ohm. And then Z at inductance, which is where we're going to calculate J times, we got this JWL, which is the general formula. We got J times 16 pi, the omega, and then L, which is the inductance value, which is 15. I didn't write it here. And then we'll just complete the equation, and we got 1252.39 at the degree of 0.65. And then we're going to calculate the current, which is Vs or V input over Z total. So we put the V input here, 5 volt at 90-degree angle over the one that we got, the Z total here. Input the value, and then we will get the value of current on ampere. And then we're going to find the voltage on resistor, the VR, which is of course the general one is V equals to IR, and then we're just going to substitute the value. VR equals to IR equals to, we're gonna put the value of I, which is what we have obtained up here, and then we're going to put the values resistance, which is resistance, which is 1000 ohm. We'll put it over here, and then we will get the VR with its own respective angle, which is the same as, oh no, not the same, which is 4 volt instead of this 0.004. And then we're going to find the voltage on the inductance, which is equals to V out, because it's on the V out region. V in is different because resistor is here. We don't have any resistor, so we will just input the value, which is, we got the value of what have we already got, the voltage on the resistor for the angle of 1.39 times the JWL, the times the Z at inductance, which is we're going to calculate here because we don't have it. So which is 16 pi on the omega, and L is 15 hertz, 15 Henry, sorry. And then we will get 3.02 volt in the degree angle of 2.96. I didn't write the what do you call it, volt over here on this one. And then V total is equals to V input plus V output. So we just um we just plus both of these, V on the resistor and V on the voltage on inductance, and we will get 5.01 volt in the degree angle of 2.04. And then we're going to calculate the phase shift, which is shift 10 um times omega L over P. Oh no, it's not P, it's R. I wrote it wrongly. I'm so sorry. So we will get we're going to input all of the values here. We already know it. Omega 16 pi. The inductance is 15 Henry, and then the resistance is 1000 ohm, and then we will get 0.64 degree because of 10 tangent -1 shift tangent here. And then this is the phase shift that we already got, and we're done with this question. Thank you. We're gonna cut to the chase. Let's proceed to the question 2, and then we have this question here. It gives the value, all of the values, and 2 graphs. And also, I'm going to go with 1B also because my metric number end with an even number, so I'm going to use resistor and capacitor, and I'm also going to do a simulation on Ltspice. So, I'm sorry, apologize for the inconvenience. I'm going to continue with my Ltspice presentation. So this is the circuit. I have already pre-made it because it is hard uh, to make on my own. So I'm going to of course we're going to put the voltage output V input on this left side, and then we're going to do a parallel mini circuit here, which consists of resistor number 1, which have 1000 or 1k 1 kilo ohm, and then we're going to put a capacitor, the first capacitor, which is 0.159 or 0.16 microfarad, I think. And then we're going to assemble the circuit with the next resistor here, which is the second resistor, which has 3 kilo ohm, and then the second capacitor, which is 5.3 nanofarad. And then we just assemble all of the circuit, put all the lines together, and then we're going to put the ground. Of course, every circuit need the ground. And then we have this V output here and V input. Label it V input on the left side, close to the voltage source, and then V output on the right side, right at the end of the line on the resistor 1 and the parallel mini circuit. And then we're going to press simulate, configure analysis, and then we're going to use the SC analysis and not the normal transient one, because we are using an band stop filter, which is a low pass. connected because we have a mini parallel circuit here, so it's a band stop filter. We have to use the acid analysis, and we're just gonna choose the decade type of sweep. Number of points per decade, 10,000. Start frequency 1. Stop frequency is 100,000 K. All right, and then press OK, and then we're going to run this whole circuit. Put the graph here. Smallify it. Minimize. I'm sorry. We're going to run the circuit, the V input over here. We're going to have a straight line, and then we put another on V output, which is over here, and we get this graph over here. So this graph, similar to the graph that we already obtained in this um, uh, figure over here in the question, which is the amplitude, negative side, until negative 270 on the negative 1 degree. Okay, and then we're going to continue to the calculation, which is calculation number 2. I have the same graph over here. So we have to state the band stop filter, what type of graph is this, what type of transistor is this. So I just put band stop filter is obtained by low pass and high pass filters are connected in parallel because they have parallel. And then we're going to continue with the calculation. We calculate the frequency with the R resistor and capacitor formula over here, and then we just substitute all of it, and we can obtain the 0.00015 on the R1C1, and then 1.59 times 10 to the power of negative 5 on R2C2. And then we're going to assume that R1 is 1 kilo ohm and R2 is 8K kilo ohm. 1 kilo ohm and 8 kilo ohm. And then we're going to assume another one is C1 is 0.159 microfarad, and then the capacitor 2, 5.3 nanofarad, and they're just going to substitute on R1, C1, R2, C2, and then we're going to find that it is a low pass and high pass connected in a parallel, and consider it as a band stop filter. Thank you for hearing my presentation.